In the last video, I grouped all the graphs into quadratics, cubics, and quartics. And then I decided that I would use this particular quartic and show you how to graph each derivative from that particular function. So we came up here starting with a quartic, and then we did the derivative of the quartic, which became a cubic, and then we did the derivative of the cubic, which became and that would have been dash 2, which became a quadratic, and finally we could go all the way up to what we would call dash 3, if you like, and that became linear. So now I want to have a look at a one which may be a little bit harder, because this one only had minimums and maximums. But if you have a look at this one over here, but I will redraw it so that it will be reflected in the y-axis like that. Okay. Now, which means that what I want is to have that minimum over here and the stationary points over here. Okay, and minimum over here. It's not easy to draw, so I'll do a cutout. This graph represents my sketch over here, so you can see it a lot better. Now you can see now that it's got a minimum stationary point, and it's got another stationary point here, which is the stationary point of inflection. Both are stationary points because they all got to have a horizontal gradient, and also because I once mentioned before, I can have a little person standing on it, so that means he can stand on it. Stand for stationary. So this is our function, and now we're going to draw our derivative function. In drawing the derivative function f dash x, we need to now first of all look at number 1 and establish where maxima and the minima. But we need to add now here that we also want to establish where the stationary point of inflection is. And therefore we mark it on the graph here on the 0 x-axis, and also on this part here by drawing a vertical line, dashed line. And now we need to highlight the parts where the function and where the slope of that function is positive or negative. So it's obvious that on this side our slope is going to be positive. So I'm just highlighting it all in green. And it's also obvious that on the left-hand side my slope is going to be negative. So using the rule 3 and 4, the positive slope will be shown above the x-axis, and the negative slope will be shown below the x-axis. Our negative slope here on the left now will have to be below this on the x-axis, but let's just examine what it actually looks like. That slope starts off very, very negatively high. So okay, it's negative, and it then starts to decrease in its gradient until it gets to a point where the slope is very, very small and negative, and where that little man is standing, it is now 0. So we can now confidently start with a very negative point on our derivative function and start drawing the slope as it goes to 0. And at this point, you also need to realize that between the minima and the stationary point, there is going to be another point of inflection over here, which is going to be non-stationary. And I'll show you why this is happening over here. So if I go and examine that one very carefully, our slope, it starts off positive. Its gradient begins to get larger and larger until somewhere about there, it's quite steep. But once you get over that, it begins to decrease. So the slope begins to get smaller. It decreases until we get to this stationary point where it is 0. So to draw the derivative function line, we need to see the slope going steeper and then decreasing again. So if I was to bring this back, and now we start to draw, where are we going to? We need to probably draw that line from that point down to about here. And what we're drawing is up and returning back to 0. So this green point over here is a point of inflection, but it is not a stationary. We don't call it stationary because the meaning of the stationary was the fact that we could make the little man stand on it. And finally, we should examine the last zone of this graph, which is coming here. Let's have a look over here from that man all the way up to the top. And if we just have a look at the way that this slope is progressing, it's again a positive slope with a very small positive gradient, and this gradient gets to be larger, bigger, steeper until it reaches up high. So we're going to translate that onto our derivative function as it's once again going to go up and up and up. If you examine the original function, you know that it is a quartic. Now, quartic is known to have 3 stationary points, or should have 3 stationary points. So they have to be stationary, not non-stationary. In fact, one of them here is a minima, and the other two are the points of inflection. They're considered to be 2 stationary points of inflection. So that's altogether 3 stationary. You might call it 3 stationary points. And there is 1 non-stationary point of inflection. Now, because we've gone down and derived it, we now will have a cubic. And cubic will have 2 stationary points. And in this case, we actually have one is a maxima and the other one is going to be a minima. That's what we have. So we now need to draw, if we're going to be drawing the derivative of that derivative, as we said before, we need to establish where the maxima and minima are. In this case here, the maxima is here and the minima is over here. So we need to draw another set of axes. And like before, these 2 points become the zeros of the new function we can say double x. So now once again, we're going to find out whether the slope is positive or negative. And if we look at this, where is our negative slope? Our negative slope is, it's going to be highlighted in the center here between the maxima and minima, and our positive slope is going to be on either side. And please note that between any maxima and any minima, you will find a non-stationary point of inflection, which will be right here. So we should really also note that. And so the positive slope must be shown above the x-axis, and that's how it will be shown up here. And of course, the middle section is the negative slope, which will be shown below the x-axis, where it comes up to a minimum and then comes back again to this bit. So we now have another minima over here. And this now is our quadratic graph. Quadratic now has one stationary point, and in this case stationary point, and in this case it will be a minima. Now this will now translate if we draw the f triple dash, because we're going to derive this again. Draw another axis and determine where the 0 is, where it was the minima, and the negative slope is on the left hand side and the positive slope is on the right hand side. So the positive numbers will now be on the right, and the negative numbers will be on the left. And we have a linear function. Okay. We don't need to go any further.